Hi, today I'd like to talk about representing numbers with lines and what happens when we operate on them. So to start off with, let's pick a number, let's say like 203. So I'll represent it as 203, and with lines I'll use two diagonal lines to represent the 200. And then I'll just use a dotted line in the middle to represent a 0. And again, three solid lines to represent 3. Okay, so now, let's say now I'm going to represent the number 12. Okay, it's going to be represented by one solid line and two more solid lines. Okay. In this case, I can put a dotted line in front just to say that's 0, 1, 2. Okay, so now we're gonna go ahead and count the areas where they cross. Okay, so let's say here I see 6 crossings here. Okay, and so now up here I see 3 crossings. And I'm only measuring where it crosses a solid line, not a dotted line. So there are 3 cases where solid lines cross each other in this one. So I'll put a 3 right there. Okay. And coming up to here, I see 4 solid lines crossing. Okay. And coming up to the next one here, I see 2 solid lines crossing. And here there's no solid lines crossing each other. So here we'll have 2, 4, 3, 6. Interestingly enough, 203 multiplied by 12 gave 2,436. Okay, so maybe that's just a coincidence. So let's take another one. Okay, so let's go ahead and look at 27 and 34. Okay, so 27 going to represent as 2 solid lines to represent the 2, and then 7 solid lines. 1, 2, 3, 4, 5, 6, 7. Okay, and so now I'm going to represent the 34 as 3 solid lines. 1, 2, 3, and then 4 solid lines. 1, 2, 3, 4. And so now I'm going to go ahead and count up these. Okay, so that's a total of 28 crossings. Okay, 2, 8. Okay, and here now I'm going to look at where the solid lines cross in this here. So we have 21 here, and here we have 8. So I'll call that 29, and I'm just going to make sure that the last digit is staggered over from the last digit here. Okay, so 29, and over here we have 6, and again the last digit 6 is again staggered. Okay, so we have 8, 2 and 9, 11. Okay, 1 and 2, 3 and 6, 9. Oddly enough, okay, if we multiply 27 times 34, okay, we get 8, 1, 0, 4, 7, 28. And when we do this, we get 918. Okay? So, now that must be an incredible coincidence. So this time, we're going to try a third set. Third set, we'll try 12 by 25. Okay, so 12 is represented as a 1 and a 2, and 25 is represented by 2 followed by 5 solid lines. 1, 2, 3, 4, 5. Okay, so here we have 10 crossings. Over there we have 4 plus 5, so we have 9. And again, the digits, I stagger them, so the last one from this column is 1 over from the last one on that column, and I'm going to stagger this one here too. So here we have 2 crossings, and I put it right there. So we have 0, 1 and 9, 10, carry the 1, that's 300. So now I'll multiply 12 by 25. Okay, 2 ways I can do, so I can just say 25 times 4 is 100 times 3. That makes 300, but I'll do it the conventional way. So 250 and 50, that's 300. So essentially what we're saying is that by crossing lines and counting them, this is a valid way to multiply. The primary difference between this one and the conventional way is that this method, the method with lines, uses a little bit more paper. However, it requires absolutely no memorization of timetables. Anyway, that is all I have for now, and thank you very much for watching.